In the previous lecture, we talked about Lewis structure of elements and that valence electrons are represented as dots surrounding the element sample. But how can we draw the Lewis structure for molecules and polyatomic ions where there are bonds between atoms? Here you can see water molecule has 3 atoms, 2 hydrogen atoms and 1 oxygen atom, bonded together to form the water molecule. Remember, oxygen has 6 valence electrons and hydrogen has 1 valence electron. Oxygen needs 2 electrons to fulfill the octet rule, and each hydrogen atom needs 1 electron to have 2 electrons filling the K shell. So the oxygen atom bonds to the 2 hydrogens with a polar covalent bond. Polar because the difference in the electronegativity is around 1.4, which is between 0.5 and 1.9. Let's draw the Lewis structure for the water molecule. First, oxygen has 6 electrons, then each atom has 1 single electron. The 2 electrons in this side form a bond, and the other 2 electrons form the second covalent bond. Now let's count the electrons surrounding the oxygen atom. Each bond represents 2 electrons. 1, 2, 3, 4, and the rest of the electrons are shown as 1, 2, 3, 4. 2 lone pairs. So 2 bonds equal to 4 electrons and 2 lone pairs which are equal to another 4 electrons. By that, oxygen is surrounded by 8 electrons. Now, for this hydrogen atom, the 2 electrons are the bonding electrons. Again, every 2 electrons represents 1 bond. We call them bonding electrons. The unpaired electrons are called non-bonding electrons or unshared electrons, and every 2 forms 1 pair of electrons. Let's look at this exercise. Write down the Lewis structure for carbon dioxide and methanol. First, carbon dioxide. Carbon has 4 valence electrons and oxygen has 6 valence electrons. For carbon to satisfy the octet rule, it needs another 4 electrons, so we draw a double bond from each side. Moving to methanol, carbon is the central atom surrounded by oxygen and 3 hydrogens from the other side. If you looked at each hydrogen, it is singly bonded with 2 electrons. Oxygen has 6 valence electrons. If we draw a bond between the carbon and the oxygen from this side and hydrogen from the other side, there will be 4 left unshared electrons. We can draw them as 2 lone pairs. We can also draw the Lewis structure from the hydrocarbon condensed structural formula. Let's look at how to draw the Lewis structure for methyl butyrate. It has 5 carbons. We can draw 4 of them in row. The 4th carbon is bonded to 2 oxygens. One of them is connected to the 5th carbon. The first carbon from the left is bonded to 3 hydrogens. The second carbon is connected to 2 hydrogens. The third is to 2 hydrogens as well. Notice that each of the 3 carbons has 4 valence electrons and it is surrounded by 4 bonds to have the 8 electrons. Now, for the 4th carbon, it has 4 valence electrons. We connect the carbon with this oxygen from this side and with another oxygen. Now, if we count the electrons surrounding this carbon, 1, 2, 3, 4, 5, 6. So we need another bond to satisfy the octet rule. 7, 8. Moving to the last carbon that is bonded to this oxygen. 4 valence electrons bonded to 4 atoms, 3 hydrogens and 1 oxygen. Now moving to the top oxygen, it has 4 bonded electrons. 1, 2, 3, 4. So we have 2 lone pairs of electrons, one on the top and one at the bottom. The second oxygen, 2 electrons from 2 sides are bonded to 2 carbon atoms. So we need to draw the remaining 4 electrons as lone pairs, 2 at the top and 2 at the bottom.